To the learning of computer networks and security. We are going to start with the module 5, that is multimedia networking. After discussing about RTP, now we will go to the next protocol that we have in VoIP, that is for conferencing, video conferencing or audio conferencing. We have a new protocol called SIP, Session Initiation Protocol. This protocol is also mainly used for conversational application. So you can see here, you can call this session initiation protocol as a lightweight protocol. This is mainly used for all telephone calls, especially where audio exchange takes place. So if I take an example of telephone call, it can also be used for video conference calls. It can also be used for video conferencing, but this is mainly for the audio exchange between the sender and receiver. Okay, so we will see here with an example how the telephone conversation takes place with the help of this protocol, session initialization protocol. So here, as you all know, whenever the two people are interacting, definitely those two people will be identified by their names first. So sender should know the receiver's name, receiver should know the sender's name. So, or at least they should know the email addresses, or they should know at least if they are using the phone to do the conversation, so there at least their phone numbers should be known, right? So through email you can do the conversation, or through phone, or maybe there are many other ways. Through their names also you can start with the conversation. So this is actually a general concept. So the same concept actually is used here in SIP also for the conversation. So here in order to reach a callee to whom you are speaking, even if that callee roams, the caller should not be bothered about that. So caller's connection should be still maintained even if the callee is roaming from one place to the other place. So callee may be, if both are using their device, that is phone, to speak to each other, so callee may not be stagnant, he may be moving, so that should not be bothered there for the conversation there. So all these will be actually maintained by this session initiation protocol. We will see the services provided by SIP. So what are the services provided by SIP? So we have mainly the services. So first service you can call it as, it actually provides the mechanism for establishing the calls, call establishment between the caller and callee. So here what happens actually there? See, the caller will be, SIP allows the caller here to notify the callee that it wants to call. So what the caller will do first, he will just notify the callee, caller will notify the callee that he wants to speak to him. So what the callee should do, if he is not busy, if he is not speaking to someone else, the callee here should be sending back the response saying that he is ready to accept the call. So this you call it as call establishment stage, and you can call this as something like in TCP what we had seen, connection establishment stage, right? So the same thing happens here, and that is actually the service provided by SIP, session initiation, that is made by SIP. So this is one of the main service here. The next service is SIP actually allows here the caller to find out the current IP address of the callee. So here the callee may be roaming, right? So whenever he is moving from one place to the other place, his IP address may change. So what is that IP address? Changing IP address, you call it as subnet address, which keeps on changing. So that new subnet addresses, whenever the callee roams, that new address should be known to caller there. So caller, in order to continue the connection with callee, that new IP addresses should be sent here to caller. So that is also sent by SIP. Okay, session initiation protocol. That is the second service provided by SIP, determining the current IP address. And the last service is nothing but the call management. So what is call management? Suppose here if a new media streams should be added during the call, or maybe something like new media streams means if suppose new streams, next audio streams or new video streams should be added here, in that case SIP will help. Or suppose whenever, see here, the call once you initiate the call, next audio will be exchanged, so audio will be sent in the form of encoded, so encoded audio will be sent there, right? So if at all in between you want to change the encoding scheme during the call, in that case also SIP will help you out in changing the encoding scheme. Okay, suppose if it is a conference call, if you want to invite new participants, then that also will be provided by SIP. And suppose in between, if the callee wants to transfer the call to somebody, or if he wants to hold the call, so that is also provided by SIP. So SIP is the one which provides all these services for the callee as well as caller. Okay, so first we will see the first service, how setting up call is made here using SIP. We will see setting up call to known IP address. So to known IP address. So how this is made possible, we will see. So here, as I already said, SIP is mainly used for connection establishment or call establishment between the caller and callee. So here let's assume that there are two people who wants to involve in conversation. So Alice and Bob. So Alice wants to call Bob now. So assume that Alice knows the IP address well in advance about Bob. Okay, so IP address of Bob is known to Alice. Let's assume that. Okay, so here now when Alice will try to call Bob, first using SIP, she will send an invite message. So you can see a keyword invite is used. So first Alice will be running SIP, so she will initiate SIP in her system. So once the SIP is launched in Alice system, so SIP session is going to begin. So as a part of this beginning of SIP, first invite message is sent to the receiver. Who is the receiver here? Bob is the person whom Alice wants to connect. So for which she should know Bob's address, right? So you can see here Bob's ID is known. This is not the email address of Bob. This is not the IP address also of Bob. This is just the ID, unique ID of Bob, SIP ID of Bob. So how is it? Bob at 193.64.210.89. This is the Bob. This is Bob's ID. So next you can see along with that she also has added the next line there. In IP4 167.180.112.24. So what is that she's trying to say in second line? She's just inserted her own address in the second line. So what is she trying to say? She is trying to develop the connection between herself and Bob. The next thing is she's trying to say her own address, and in the third line she's saying that she's expecting audio. She's expecting audio from Bob. And how should be the audio? Audio should be in the form of RTP packet that should be sent to Alice. Okay, and the encoding technique what she is expecting is AVP0. This is the encoding technique that she is expecting. This encoded audio in the form of RTP packet should be sent to Alice at port number 38060. So 38060 is a port running here at Alice side. RTP packet she is expecting, audio message she is expecting, and the encoding technique also she has specified. So all these information she will insert, and she will be sending now that information to Bob to a particular port number. Assume that this port number is known to Alice well in advance, 5060. See here, remember for SIP, a common SIP session, that is for connection establishment, a common port number is used for both at the Alice end and at the Bob's end. So here, what is that common port number? 5060 is the port number. So Alice is sending now the message to Bob at ports 5060. Now what Bob has to do? If Bob is not busy, Bob will simply send an acknowledgement. So response message. So what is response message? It is a success message. 200 OK indicates success. And now Bob also will insert few lines and send. So what is it saying? He is just inserting his own address. And what is that address? 193.64.210.89. And he's also saying that Bob is also expecting some audio in the form of RTP, but the encoding technique that Bob is following is AVP3. That is the encoding technique that he is expecting, and then he wants the audio message at port number 48753. So this is the one message what Bob is sending to Alice. Again, you see the same SIP port number is used, 5060, for which the message is sent to Alice. Now what Alice can do, if Alice is not busy, again Alice can accept the connection, accept the request sent by Bob. Now both have agreed to start the conversation. So Alice will send an acknowledgement back to Bob. Okay, so this completes the connection establishment. So both have agreed to establish the connection. So you can call now this SIP session has completed. So this is SIP session which has happened here between Alice and Bob. And now you can see who will begin the conversation. Bob should begin the conversation because Alice had requested first. And now you can see here onwards the audio message is actually transferred in the form of RTP packet. So audio message, you can see audio signals are transmitted from Bob to Alice. And what is the encoding scheme? What Alice is expecting? Alice is expecting AVP0. The same encoding scheme is used, and Bob has sent the audio to which port? So Alice port is 38060, which she had specified, to the same port he has sent. Now Alice has to send the audio message back to Bob. So again she is using a technique, encoding technique, which was specified by Bob there, AVP3, and then it is sent in the form of RTP stream only. And to which port number she is sending? 48753. So this is how the audio messages are exchanged between Alice and Bob. So remember, you call this as out of band. So SIP is actually out of band. What is out of band? Connection establishment has happened separately and data transfer is happening separately. So here you call this as out of band, right? So this is something similar to our HTTP that is happening. So you can see this first request message is in the form of HTTP request. The second message what Bob is sending is in the form of HTTP response. So somewhere this is similar to HTTP. And this out of band thing, you remember in FTP we had this out of band concept. So here connection establishment is separate and data connection is separate there. So you call this as out of band also there. Okay, so I hope this concept is clear. That is the communication happening between SIP or communication happening between the caller and callee there. So this is the thing there, example there. So you can also have one more possibility. Call can be rejected by Bob. So if suppose Bob is busy, he can reply with the busy, gone, payment. So this type of thing also can happen. So remember here in SIP, actually this supports ASCII. So this supports ASCII. So which are the commands are invite, then in. So all those are the commands used there for conversation. So that supports ASCII there in SIP. So here apart from that, Bob also can reply with busy, gone, and all those also is possible. And suppose if he is not ready there, so such type of response also can be sent. Instead of 200 okay, 6 not acceptable. Such type of messages also can be sent by Bob. Suppose if the encoding technique is not available at Bob, he can send such a response message. Okay, so this type of messages also can be exchanged in as a part of SIP. We have an example here of SIP message. So what is an example? You can just go through those lines there of SIP message. So we have several lines. First line is invite, next via, next from, next to we have, and next we have call ID, and then the content type, and then the content length. Yes, so all these are the lines. So you can just see here, this message format is somewhere similar to our HTTP message format. So this is actually the SIP message carried from say Alice to Bob. So how is it? So first the invite command is used where Alice is trying to invite Bob for conversation. And you can see here SIP is a protocol that is used, that is appended there to Bob's ID. So Bob's ID may be known to Alice. So you can see here Bob's ID may be in this format, bob@domain.com, which might be the domain. So if Bob is owning the website, his website address also can be known. His email address can also be used there. So bob@. So this is a ID, SIP ID, which is known to now Alice say. So what is SIP version, protocol version? 2.0 is used. Next is actually via. So via, actually what she's sending, Alice is sending this SIP message. You can see if Alice IP address is 167.180.112.24, via this device, via this particular device address, she's sending this invite message. So there you would Bob may be nomad, Bob may be roaming from one device to the other, or maybe one network to the other network, so his IP address may keep on changing, right? But the first address, first session, when the SIP session is initiated, it is through this IP address what the address is, what the this particular SIP message is sent. So that is the meaning there. So via thing. And next we have from. So from is Alice address, to is Bob's address, and you can see both the IDs of Alice and Bob are appended with SIP. And now you can see call ID. So this is nothing but the caller's ID there. So what is that caller ID? It is specified there as this call ID actually specifies, it uniquely identifies the call. So it is something like similar to message ID in the email there. Okay, so here call ID, this ID is specific to this particular message that is transferred from Alice to Bob, this ID. Next, content type. So what is the type of the content? See here, this portion is actually the content. So what is the content type? Application type or SDP. So this is application type of content that is embedding and sending. And how many bytes he is inserted here in the content? 885 bytes. And you can see here what is the content. This is a message what Alice has typed. She has simply typed her own address. 167.180.112.24 is her own address, IP address, and she is saying, trying to say that she is expecting audio message at port 38060 in the form of RTP packet, and the encoding scheme is AVP. So this is what the SIP message that is generated at Alice end, which should be now sent to Bob. Till now we have seen how Alice can locate Bob, or how Alice can initiate SIP session with the remote Bob. So wherein Alice will know Bob's ID, also Bob, in order to send the response back to Alice, Bob also will know the Alice ID. So with the known IDs of each other, Alice and Bob will be able to generate SIP session there. So now we will see here how the translation, name translation and user location, so this could be done there. So here let's assume that Alice is a caller and Bob is callee. Okay, so Alice wants to call Bob. So when Alice wants to initiate a SIP session there, Alice should know Bob's ID, right? But here let's assume that Bob's ID is not known to Alice, or let's see the other way around also. Here let's assume that Bob will have an ID, something like Bob at something like somedomain.com. Okay, Bob at somedomain.com. So that ID is known to Alice, but in reality Bob would have changed his location. So the meaning is Bob would have moved from one location to the other location, or Bob would have changed his device. So what happens when Bob moves from one location to other location, or what happens when Bob changes his device? So all that changes there is the IP address of Bob. So this IP address of Bob, when it changes, that changed IP address should be notified back to Alice in order to develop a SIP session between Alice and Bob. Okay, so what is that? Initially Alice will be knowing the ID of Bob, something like Bob at domain.com, but this Bob would have changed his location, that is he would have moved from his location to the other location. In that case, IP address keeps changing. So I hope you already know about subnet address. Also, might be Bob is changing his device. When he is at office, he might be using some device, and when he moves back to his home, he might be using his home device. Even in that case, IP address changes. So this changed IP address, about this changed IP address, it should be known to Alice in order to communicate or in order to develop SIP session. So let's see what happens now. Actually, here it is Bob only, the person who should notify back about his changed IP address to Alice. So that is how Alice will come to know about this changed IP address. Now let's see whether Bob himself will report about this changed IP address to Alice, or whether Alice will come to know about this changed IP address through some other intermediate device. We have an intermediate device between Alice and Bob called registrar, which will really help us out in finding the IP address of nomadic Bob. Okay, so here what is the meaning of this? We have here Alice and Bob. Alice wants to develop a SIP session between a SIP session with Bob. So for that, Alice should know Bob's ID, right? So what ID here Bob has, that Bob's ID is Bob at domain.com, say, and that is the ID which is known to Alice. So with the help of which she will send a invite message to Bob. But here what has happened, Bob is not in one fixed position. He might have changed his location, or he might have changed his device. So because of that, his IP address or his ID would have been changed. So here we have an intermediate device called registrar, which will help us in finding Bob's new IP address. So here registrar is an intermediate device which must be running in an intermediate system, or let's call it as a server which runs registrar. So whenever here Bob moves to a new location, maybe from office to home, or maybe when Bob changes his device, his new IP address will be sent to this registrar. So it is something like whenever Bob launches his SIP session, when Bob will launch SIP session, initially when he is in one particular system, say Bob at domain.com, once he launches his SIP session there, his IP address will be sent to this intermediate device or this intermediate server where registrar is running. So his IP address will be known to this registrar first, and when now Bob changes his device, or when he changes his location, his new IP address there in his new device or in his new location, once he launches his SIP session there, so his new address, his new ID will be again sent to this registrar. Okay, so you can call it as now new registrar, to which Bob will send his address. So it is something like for every location, for every device, Bob will be associated with the registrar. So his IP address will be known to registrar. Again, when Bob changes his device or Bob changes his location, when he launches his new SIP session, his new address will be sent to a new registrar. So he'll be now associated with the new registrar. So it is through registrar here Bob's new IP addresses can be located, and it is this registrar now who should be contacted by Alice in order to know new IP address of Bob. Okay, so it is this registrar which will give the information about the new IP address of Bob to Alice. So here this is what is happening. So similarly, it is not only Bob who is associated with registrar, Alice also is associated with her registrar. So when Alice initiates SIP session, she will be associated, or her IP address will be sent to her registrar. And when Alice also wants to change her location, or if she is changing her device, her new SIP session what she wants to create from her new device or new location, that new IP address also should be sent to her new registrar. Okay, so Alice also will be associated with her registrar. And now you can see here the format or syntax of a register message. So what is that? A new IP address, or how the registration happens here. So initially here you can see register. So it is the domain, what say Bob is sending. So sipdomain.com. So it is just to tell you about the SIP version here 2.0, and now it is also telling here say Bob's domain is notified here through this. So Bob is trying to register his IP address now, and here you can see via the UDP underlying protocol he is sending this registrar message using UDP as underlying protocol. And you can see here this is the IP address now what Bob is currently using. Okay, and now you can just see here from Bob, it is the address of Bob now where he is sending, and to whom he is sending now. Again this is sent to the registrar here, and he is trying to say that this IP address duration, the surviving duration of this new IP address is just for 3600 seconds. So after 3600 seconds, here the IP address or this ID details should be refreshed. Okay, so registrar will have to get re-registration message for every 3600 seconds. Okay, so this is how the registration message is sent from Bob to the registrar. Okay, so it is something like that. So here within this 3600 seconds, maybe Bob, I mean within the throughout this duration Bob may remain at the same device, or maybe if Bob still wants to remain in the same device even after 3600 seconds, he will have to send a refresh registrar message. Suppose if he is changing his device there within this 3600 seconds, that new registration message should be again sent to the new registrar. Okay, so here this, remember, this registration message is sent to registrar in order to track Bob's current IP address. Okay, so this is how the registration is done, and this is somewhat similar to our DNS messages. So I hope you all remember about DNS. DNS is mainly used for translating host name into IP address, right? So here this is something like the one which is used to translate Bob's ID into new IP address. Okay, so this is actually done here first in order this is actually done something like in order to have a SIP communication. So in order to have that, this registrar will help the sender to know the changing IP addresses of receiver. Okay, so this is how the registration takes place. So far about the registrar, whatever I was saying, this is actually done through an intermediate server called proxy server. So our registrar here is running at this proxy server. So this proxy server is the one now which is in between our Alice, sender, who is sender, and Bob, one who is receiver. So here Bob is moving from one location to the other location. So Bob is sending this register message to the registrar, and where is the registrar running? So registrar is running at this proxy server. So it is this proxy server which is contacted by Alice in order to know the IP address, current IP address of Bob. Okay, so registrar is running at the intermediate device, and the device is proxy. Okay, you can just see here Alice sends initially invite message to her proxy server or to her registrar, Okay, so this proxy should be there for Alice, that is her registrar, and there is again a proxy here or a registrar which is running for Bob. Okay, which is running for Bob. So here initially invite message is sent to Alice proxy server containing the address, SIP address of bob@domain.com. This is a address known to Alice. Now proxy is responsible. Proxy of whom? Proxy of Alice is responsible for routing this SIP messages to proxy of Bob. So here proxy of Alice should know the address of proxy of Bob. So here Bob will send the response message back through the same set of SIP proxies. So he will again, Bob also can send the SIP message, reply message to his proxy first, and it is through proxy of Bob which will be sent, the response will be sent to proxy of Alice first, and then from the proxy of Alice it will reach Alice system. Okay, this is somewhere similar to our DNS. Yes, let's take an example over here. So how two are communicating through SIP, or how SIP session is initialized and how the communication takes place. So let's here take two people. One is Jim who wants to call other person Keith. Okay, so Jim wants to call up Keith. So caller is Jim, callee is Keith. So here let's assume that Keith is the one who is nomadic. He keeps on changing his device, or maybe he keeps on changing his location. Okay, so first, what is the first step? So let's assume that the current address or the IP address what Jim is using, where Jim is running his SIP session, or his SIP is launched here in this system, whose IP address is 128.119.40.186. So Jim is using the system, his SIP is launched here in the system. So now he wants to communicate Keith. So Keith's address is known to Jim, but what is the address that is known to Jim? That is keith@poly.edu. So with the help of that address, keith@poly.edu, Jim will first send the invite message to who, where? Not directly to Keith. So you can see Keith is here. Keith is using the device whose IP address is 197.87.54.21. So here Jim cannot directly communicate with the Keith, or SIP session cannot be generated between Jim and Keith here. So what Jim has to do first, he has to send an invite message to the proxy or the registrar which is owned by Jim, which is applicable to only Jim. So what Jim is doing first, invite message is sending to his own proxy. So UMass SIP proxy is the one. So what Jim is using, so you can just see the domain of Jim, it is umass.edu. So definitely Jim's query will be sent, or invite message is sent to the server or the proxy, which is whose name is, or the domain is umass.edu. So now what this proxy should do, so with the help of the address, destination address, what is the destination address? Keith@poly.edu. So this poly.edu will be known to this now proxy server. Proxy will read that poly.edu. With the help of that, now our proxy will send the query or the message directly to poly.edu poly registrar. So this poly.edu is actually again a proxy server where the registrar is running. So here the message is sent. So now let's assume that our Keith has changed the domain. He is nomadic, right? He has changed his IP address. He has moved to a new location. So his address is changed. His domain is changed to yourcom.edu. So it is something like yourcom.edu. So it is the new domain or the new address of Keith. So what Keith can do now? So if suppose a close friend of Keith is calling him, then what Keith can do, he can simply send one Keith can have a web page which should be stored in proxy server, so that it is something like, Keith is leaving a message behind in his proxy server for his close friends call, for his close friends, so that web page will have a response, auto response kind of thing for all his close friends. So what might be that response? Something like please wait, or please call up after some time, something like that. Response message also can be left behind by Keith. So it is something like Keith is sending one auto response message. That is in the case where Keith might be busy, or Keith might have moved on, out of station or something like that. Okay, such things also can be done here through SIP session. So what is that Keith is doing? When Keith is moving to a new location, suppose his friends is not able to contact him, so Keith can leave behind one web page or a response message in his proxy, so that whenever his close friends calls him, his friends call will reach his proxy server. So once the proxy receives such close friends call, he will identify those those source addresses, and with the help of which our proxy will automatically open up that web page where the response of Keith is available, or that message is available. So automatically that response will be sent back to friends of Keith. So that also can be done. Okay, so now what is happening? We are here the message is sent to the poly.edu, but unfortunately Keith is not anymore associated with the poly.edu. So Keith has moved on to urecom.edu or something. So his new registrar is this. So now this poly.edu, so whenever Keith changes his registrar, his new registrar information should be sent to the old registrar. So old registrar should have the information about this new registrar. So definitely this poly.edu, this registrar will send a response message back to UMass proxy, UMass registrar. So UMass registrar is owned by Jim. So this is where Jim is associated with. So a response message is sent back. So what is that response message containing? It is containing now the domain or the address of ure.com register. So ure.com or urecom.edu register. So this particular ure.com, let's take it as ure.com. So this address of the new registrar of Keith is sent back to proxy. So now again what UMass proxy does, UMass proxy can directly communicate with ure.com registrar. So this is the new registrar to which Keith is associated. Suppose if Keith has left behind any response message or any web page, so directly the response will be sent back here itself from the registrar, or else if Keith is free to receive, then here this request will be redirected directly from registrar to Keith. If it is an email or if it is a message, directly that will be forwarded to Keith. So Keith will be launching his SIP session. Once he launches his SIP session, so now Keith will be able to receive this message what Jim has sent. So accordingly now Keith will send the response to his registrar, to his proxy system, and then proxy will send back that response to UMass proxy, which is owned by Jim, and Jim anymore will get the response from Keith, and this is how SIP session is done. SIP session is generated. Okay, so this completes the SIP communication, initial communication. Okay, once SIP communication is done, then actually RTP session will begin, where actual audio will begin, actual conversation will begin after SIP session is completed. That is RTP session will begin, and anymore now acknowledgement can be sent from Jim to Keith directly, and after that audio can be sent from Jim to Keith directly with the help of RTP session. Okay, so this I can just show you. So first step, Jim sends invite message to his own proxy. So next step, second step is here UMass proxy will try to contact the destination address what Jim is knowing, that is poly.edu registrar, but poly.edu registrar will know the new registrar of Keith, that is urecom. So that will be communicated in the third step back to UMass proxy. Now with the help of this address, UMass proxy will directly communicate to urecom registrar. So after fourth step, now it is left to Keith. If Keith is free, so if he has already launched his SIP session, then after that along the fifth step, that will be forwarded, invite message will be forwarded to Keith. So Keith can send the response message. After sixth step, seventh step, it reaches UMass proxy, and from then onwards in the eighth step, Jim receives this response back from Keith, and now here onwards acknowledgement Jim can send back to Keith directly without using any proxies. So after that, through RTP session, the audio messages can be continued. Okay, so this is how conversation is done through SIP. So this is how SIP session is generated. Okay, I hope this is clear. Data flow begins between the clients. Clients here are Jim and Keith.